Okay. Cool. Then I'm just handing over now to Davide. I think I need to stop sharing now.
Thank you very much, Max.
Yep.
Yep. Thank you for, as introduction, Davide Fioriti. Our work at the University of Pisa. I'm co-director of the initiative together with Max. And in particular, my presentation will go through, so the next hour will explain better the architecture and go through some of the points that have been touched by Max earlier. Max, maybe you need to enable me to share the screen. I cannot share the screen. You're muted also.
Just make you the host now.
Okay.
Okay, but I hope the recording won't stop then.
You should just you just don't need to make me the host, but usually there is the ability to enable that.
Okay, multiple participants can share simultaneously. I don't know. Can you share something now?
Okay, now yes. Awesome. Perfect. Okay, yeah, now it's working. Can you see the screen?
Yes, perfectly.
Awesome. Okay, so I want to start with a screen desk, so to guide you through all the points that shown Max since starting from the repository. So the main way to find documentation is always, as mentioned, the read the docs, the documentation, and in particular there have been many points raised about how to install the package, and clearly there is the installation here, and my presentation today will go through as the goal to detail better about this, the installation part and the architecture of PyPSA-Earth itself. In particular, this to understand better this activity, I will use a notebook that is available in the documentation repository that Max has shown. And to reach that repository, if you go to examples, there is the link to the documentation repository that will that contains all the details as already mentioned. In particular, in this block, if you go in the hackathon material, you can see you'll have a lot of learning material starting from the basics. In particular, there are from basics exercise like GitHub to how to install the PyPSA-Earth, and also the architecture, and also how to execute, debug, and incorporate new regions. There are some samples that we highly recommend to go you through. In particular, so maybe it's good to recap a bit the installation parts, and clearly Conda and Git are relatively simple to install. In particular, Conda, as you may use Anaconda or Miniconda. In our case, we recommend highly recommend Miniconda, that is lighter, and both of them can be accessible through this link. In particular, you can see you can choose if you want Miniconda or Anaconda, and obviously you need to check exactly the version that you need. So in particular, you need to install Windows if it is Windows, Linux if it is Linux, and Mac if it is Mac. So going back to the part, Git is another software that is similar to Conda, needs to be installed easily. And in particular, here we highlighted the concept of EDE. The EDE is a program that is used to run code, to code and to execute code. We highly recommend Visual Studio Code that as mentioned. And in fact, when you go below, there is also the link to Visual Studio Code. In particular, the presentation today will focus a lot on Visual Studio Code. In particular, I will suggest you also some elements that you should install. First of all, I'm using Windows. And this is also interesting because you have seen Linux with Macs, and with me, we are going to see Windows. And I will give you some suggestions about how to run the code in Windows with the least problems you may have. Are there Windows users here? If so, maybe raise their hands. Okay, so we have one here.
Yes.
Okay, we have some Windows user. Very good. So what I'm going to show is also useful for some. Okay, perfect. So first of all, when executing Visual Studio Code, it's highly recommended to run it as an administrator. This because when running the code, especially some solvers, they execute some internal activities that may require administrative levels, but because simply some files are not loaded. I'm saying this, and I will run now Visual Studio Code without administrative privileges, so that in the future, when we reach this problem, the problem arises, and so we are able to see what I'm talking about. Okay, so I can open Visual Studio Code. Now it's already installed. I don't think there will be problems on this point of view. And again, I want to start with a black screen in Visual Studio Code. As you can see, so before even opening the code, when you have a fresh installation of Visual Studio Code, you have to make sure to install some extensions that are seen on the left side. And in particular, I have many because I do different stuff, but those that are really required for PyPSA-Earth are for sure Python, that is necessary for executing the code, and also having all the code properly highlighted according to the Python standard. Moreover, we also another element that is needed is Jupyter, the Jupyter package, because if you have this package, you can open all the notebooks, Jupyter notebooks that you have seen, and this is required to run the code. Moreover, especially if you want to become a developer and you are interested into that, the other extension that you may need to install or verify that is installed is the GitHub pull requests and issues, because it enables interaction with GitHub that is quite easy, in my opinion, and I will show you some details also from this point of view, obviously at a graphical level. So once these elements are installed, then we are ready for running the code. As a remark, I think that other packages could be useful. For example, Git Lens to see the history of GitHub. Also some CSV and Excel viewer that can help you open CSV files in a more tabular way, which is also comfortable. And there is also, I have not installed it here, but there is also GeoViewer, Geodata Viewer, for example, that can help you read GeoJSON files and see the data into the maps. Maybe I can install it and later we can see some outputs. So now you have seen also how to install. So you just click install and you can install the package. Okay. So now we are back to our fresh. We are back to our fresh in Windows. I don't know if you see. One second. I video no. Okay, sorry, but I had the bar of Zoom that was annoying. Okay, so now we are at our new page again, and how to open the folder. In particular, you can open the folder by simply clicking Open Folder and opening the right folder. In my case, I created a special folder as well, and also created 3 versions because it's useful to show and compare elements. Now I will open a repository that is already empty. So I went through the git install as shown before, and I installed PyPSA-Earth in this folder. Now I open the folder and I can open it, and you see here that, as in the case of Max, we have all the folders installed. Note that these folders and files are only those that are available into the repo, but additional folders will be created thanks to the workflow. Now I will open on the right-hand side another Visual Studio Code with the same folder, but with all the whole workflow executed, so that we can compare the folders and we can go through better about the content of the folders. So if you are, in particular also for Windows users, if you move the window on the left, you can do this, and so it's quite comfortable to do so. I will open a new Visual Studio Code, and again, I open the other folder with the filled data. And I keep again the element here. Sorry, you went in the other screen. Okay, yes. So now we can see that we have on the left-hand side the clean repository, and on the right-hand side you see the entire repository with these green files that have been added. I will talk about this later. For the moment, disregard about these green files. In particular, the main values that are worth mentioning is, for example, the snakefile. The snakefile, now I open to clarify better the file, is the main file that is required to execute everything with snakemake. In particular, the workflow is so when we execute the workflow, but starting from the configuration file, and in particular the config file that Max has proposed you. So there is the config file that is the key element that that represents how the modeling should be executed. Then this file is used to run the workflow, the activity, and produce the output. But the output, what is the output? The output is the execution of the planning study for the given area specified in the configuration file. And to do so, in particular, we use snakemake that decomposes a large problem that enables to decompose a large problem into a number of sub-problems, each being very smaller. To explain this, I can show you with the filled element this image workflow.png that has been executed using the procedure that is available in the documentation. I will just show you, just to understand you which one it is. And in particular, it is, again, I go to the read the docs. And if you go here, you see this this image. This image is exactly, so the entire image represents the execution of, let's say, an optimization of a workflow in PyPSA-Earth that is decomposed into a number of sub-problems, and a sub-problem is represented by this block. So each block is a sub-block of the entire problem, and this image can be created using this command, using graph vids. In Windows, you can install graph vids in Windows, and as a little comment, in my case, this function couldn't be executed directly in Windows, but we can do that together now. So to reproduce exactly the same image, but for the workflow that I've shown before. So we go into the field snakemake, and we can create, we run the terminal. To run the terminal, we do run new terminal. In Windows, I highly recommend to use the prompt CMD. And by default, depending on how it is set, your Windows, the default may be PowerShell. To change the setting here, you can do View, Command Palette, and if here you specify Terminal, select default profile, and you can select the CMD. This is a command prompt. By doing this, whenever you do terminal, new terminal, CMD will appear. If you make any other choice, the other terminal will appear. As a comment, if we see through the options, we can see that there is also PowerShell, that is the PowerShell. And if you see here, there is Ubuntu. In particular, there is in Windows 10, there is the option to install the WSL that enables you to execute Linux command on Windows. But for today, I will use Windows, pure Windows, so to avoid you this need in the case you want to use only Windows. So now we have our CMD. And again, we need to create our environment. So, and to do so, it's again activate PyPSA-Earth. Now you know that the Conda environment is being activated because you see here PyPSA-Earth. Remember, now the code that had to be run was this one. In particular, Max has shown you before that to execute the entire workflow, we need the exact rule to execute is solve all networks. That's the one that he used. And if you run this, there is an error. Syntax error in line 1, near set. Why? Because, and now we can see, first of all, we can get the first command, snakemake Debug, and the Debug enables to create as an output a series of text that describes the sub-problems that are being executed to create the final output. In Windows now, if we run this element, we can see that the output yes, because this is a detail. In particular, sorry, network. I missed the R. Okay, here you see a text that I'm not about to describe. I will but if you, I want to save it as a dot file, workflow.dot, and this command in Windows means take all the output from whatever command and put it in workflow.dot. and that's the file. And if we open this file, you can see at the beginning that there are these 3 lines, and these 3 lines in Win are not supposed to be here. In Windows, this is a problem, and you just can simply delete them and save the file. Once this has been done, you can use the other part of the code that is in the documentation, and that it was .tpng output, so on. And you just need to add here workflow.dot. That is the output of it. That is exactly the file that you are watching right now. By doing this, the workflow.png has been created. And you can see here that this image is exactly the entire procedure that has been executed to execute the tutorial file, because this is the field workflow, and it is being executed the tutorial element. In particular, we can see that at the beginning we have this first rule, retrieve data bundle like maybe I can zoom in. Yeah. At the beginning, we have the retrieve data bundle light. That is the first rule that has been executed, and I will go through it a little bit better for debugging purposes. And after that, all the other rules are created. It's interesting to notice that these rules, build renewal profiles, are the same, but executed for different technologies. And the keyword technology is a critical element. And if we go, and now we are going, we will go shortly back to the snakefile, and we will see that the word technology is a so-called wildcard that is a key element to execute the workflow with the snakemake, because with the wildcards, it is possible to execute the same sub-problem in an iterative way for similar, in this case, a technology. So we are able to use the same block, but for in different conditions. For example, different clusters of different node size of the network that we want to execute, and so on. Are there questions?
Yeah. Hi, Davide.
Yep.
I'm Arijit. So could you please explain that part, that part inside of the code that previously we have seen that there is -J1 to whatever the number actually stands for the CPU code. So could you please explain that? And
absolutely. So yeah, that was. I wanted to go back. In fact, before going to the snake file, I wanted to first understand the concept of the workflow to decompose the large problem into sub-problems, and then
okay.
in fact, absolutely, yes. Terminal. Okay, let's go back to the terminal. Okay, the terminal was here. No, maybe I closed the file. Anyway, okay, now we again activate. Okay, this is it. In particular, you maybe are mentioning this function, snakemake Debug solve all networks.
Yeah.
Okay, so this code, so to run snakemake, the way to do it is, first of all, you need the keyword snakemake first. Then, if you want to execute any rule, you need to specify the number of cores that you may want, the number of threads that you may want to use in the so sorry, I first explained exactly the same element, and then I go through that topic. So the element was this one. In particular, this code means, okay, I want to use snakemake with this rule, and this is the option called DAG, that stands for directed acyclic graph. In particular, this DAG is a complex way to say this plot, basically. So when it is executed, this code, you mean what is the list of sub-problems that I need to execute to run this rule? So this is the explanation of this element. But what is mainly useful for you is not is how to actually run the model. And maybe we can do this again together, step by step, in the clean environment, or at least a few parts, and in which we explain how to use snakemake.
But yeah, in addition to it, I have another question that whenever when this you have seen just before a certain time that the 3 lines are actually coming, test not found, something else. So I need just, you suggested that we need to delete that. So
if you want to do, if you want to create these images on Windows, yes.
Okay.
Yes.
Okay.
So if you want to create the same image, like now I put it in workflow again, ... Okay, you see that this is the output, and these lines must be deleted if you want to create that image.
Okay.
The same may not apply in Linux. This is a slightly different approach. In technical level, it depends on how the operating system prints the output. Okay, so are there other questions? Because otherwise, I would like to go again into the snake file and detail a bit better what is a rule and how to run it. Okay, so now we go to the clean repository. That's it. And in particular, we can open the snake file. The snake file is composed by a lot of it's composed at the beginning with imports that are needed to specify and, for example, import the config file. We need to import, in fact, the config file. And if I don't want to focus too much on the upper part, but to give you the concept of what is a rule. And I will take a simple one. That is this one, for example, download OSM data. Download OSM data by the name has the goal of downloading the data for, in this case, cables, generators, lines, and substations from OpenStreetMap. In particular, this rule, you can see that it has the output feature, the output keyword here that explains what is the output of this rule. If we go back and show again the image of the workflow, maybe I try to zoom it, and we go to the download OSM data, you can see that this is a block, and it has the same name as the rule that you have here. And in this element, we don't only have an output arrow, because this rule creates only outputs. In particular, in fact, this is autonomous, because you can download data from OpenStreetMap and these outputs are created. Also, a log file is created, and these other feature with this code, we explained that the script needed to be executed to run the download OSM data is located here in the folder scripts. If you open the folder scripts, in fact, you see a lot of all the Python scripts that are used to execute the workflow. In fact, wherever you want to run the element, the script, so all the code that is executed in the workflow is contained into the scripts folder. So, and how you said how to execute the rule, we can do that. Activate PyPSA-Earth. And then let's say that we want to run download OSM data. First of all, I make sure I delete the I want to delete the config file to start from scratch. In Wind, if you I can do the copy and paste with the here on the left, as said, as done by Max. Particularly, I copy the tutorial and I paste it, and then we can run it. Snakemake J1 download OSM data. Now the question arises: what does J1 means? J1 it means that you want to use only one thread to execute the rules. So you can use J1, J2, J3, J4, or and it means you want to use one thread to run the workflow, which means one thread, or two threads, or three threads, and so on. If you want to enable the workflow to use all the potential power of the CPU, you can do J-all, and that applies. This is equivalent to also the same can be specified using the word course. And on the right-hand side here, download OSM data. This one is the rule that we want to execute. And if we run it, if there are no problems, hopefully, download OSM data. What's the problem? Maybe. Again, I wrote badly. I missed the N. So now the data from OpenStreetMap are being downloaded, and you can see in the log that first Nigeria data are being downloaded, and soon also the Benin data that is contained into the in the tutorial will be downloaded as well. Hopefully, the speed is fast. Yep.
A quick question from a chat. Could you please clarify where the folders, resources, OSM role, and the sources, where are they located?
Yep, that was the next part. Absolutely. So, in particular, if you see here, you have seen, for example, in the rule download SMM data that you have seen the folder resources, and also on the left you have seen the folder data. In the meantime that this is being downloaded, it's a really good time to see what the entire folder you look like, and we can see here on the left the entire folder. In particular, the critical folders are the folder data, and the folder data contains all the raw data. So whatever data is available from the web and loaded without doing any post-processing is stored into the data folder. And you can see here that we have the Copernicus data, the economic exclusive economic zone, JDM, and so on. This contains all the data. And maybe now you are going to ask me, okay, but what are all the data that we need to have, and especially what's their license? Because the data that we are downloading do have different licenses. And we created, in fact, into the read the docs folder. If you go, this is the introduction. There is the block license. And here you can see all the different data sources that we used, including the details and the license. Especially if you are interested in commercial and non-commercial activities, this is really needed to cross-check because some of the data may not be possible to use. And also, Katia will explain more about this. Are there questions regarding exactly the data? Okay, maybe then I go more.
There is a question in the chat.
Please.
Okay. The previous question was about data sources.
That's
where the command load data is from.
Okay, load data, we can see them here. So the load data are contained into the SSP2.p folder. And in this case, we use our methodology on Gegis, on the Gegis model. And maybe Katia, later, since you go through the notebooks better, maybe you can explain more about that, maybe.
Davide, a little misunderstanding here. Like, it's not about load data, it's about downloading data. So where's the data coming from?
The data sources.
Yep.
It was listed in the here. So all these are the data sets. And in particular, we can see that the data elements, you can go and click in the link and see the source. In particular, if you want to see exactly the code, what is the code that we are using, in particular, it's located into so we download the data in the scripts retrieve data bundle light and build shapes and cut out and build shapes. These are the main data that are stored into the folder data. So retrieve data bundle light and build shapes. If you go inside these links, you can find exactly the link. For example, in this case, there is the link of the JDM dataset in which we download the data and they are stored into the data JDM folder and so on.
And as a continuation of a question, when snakemake shows an error, which is telling that it can't find the data source to download, what can it mean?
So this is quite general, and then it depends. It's a case specific. Unfortunately, there is no general answer. Assuming that the workflow generally works. So we experienced problems, for example, with the JDM exactly data source, that sometimes it went down. And the problem is that maybe the data source for that element is missing. So somehow the link to that data source is broken. And in this case, if you don't find quick a solution, it's really a good point to go to Discord, our Discord channel, and ask for help. We have a chat. Maybe later in the documentation part, Katia will explain this also, how to reach with us.
Okay, I have one question.
Yep.
Yeah. So suppose when we are downloading or installing the PyPSA-Earth, initially what I can see, so 4 data are there: costs, custom power plants, and hydro capacities, and all that. And suppose we want to execute the same PyPSA for a certain region, so not for the entire Earth. So then, so how we can download all the data? So that is for a particular region as well.
So for most of the data source, it's automatic. So if you just go in the configuration file and you change here the countries, the country that you are interested to cover, from Nigeria, for example, to Africa, or Botswana or other, you just need to change
so
the
here
link.
you are showing, is it PyPSA Africa?
This is PyPSA-Earth, but this works also for Vietnam, for example, China.
Okay.
It's we started for Africa, but this applies for the world.
Okay, so that means for all the country, automatically it will be downloaded.
Yes, as a detail, it's so the tutorial version works for a few African countries, because
Yes.
the goal of the call is just to be small, but the normal workflow, which is non-tutorial version, works for the entire country. There may be bugs for some non-validated countries, but the countries under interest here have been covered, and they work.
Okay.
And if you are interested in another country, absolutely, we are absolutely available to help you navigate that.
Yeah. So it is always required. Thanks a lot. So far.
Welcome.
Okay.
So I'd like to show you and go quick through the other folders, and also highlight some other additional parts with snakemake that are important. So we covered the data folder and the data sources. Another folder that is useful is the resource folder, that contains all the processed files. So if in this folder, all the files that are created thanks to the workflow, which means they are not raw, have been located. And in particular, you can see, for example, the shapes of the country that we are considering. And for example, here you can see the GeoJSON. And do you remember the extension that I installed before, the GeoData Viewer? If you see here, this block view map, if you click on the GeoJSON, you are able to see the shape that is stored into the country shapes. And this is quite useful, because it can enable you to check quickly some data that may not be so easy to check in this file instead. Highly recommended. And this is, for example, one example of the resources. It contains different data and some OSM data and so on, and they are all detailed into the documentation for more needs. Moreover, there is the networks folder that contains the PyPSA networks that have been created throughout the notebook, and they have, each of them have incremental features stored within them. And you may say, okay, we have talked about many resources, but where are the outputs? The outputs obviously are located into the results folder. And you can see here, this is the network, the output network that is created with the workflow automatically. We also have some automatic plotting features and some summary material that is automatically created. It may be it's a quite good base. Last but not least, the folder cutouts. That is an additional input folder that is created, and this contains weather data downloaded from the Copernicus weather service. And this is it contains, for example, the temperature of temperature, humidity, wind speed, and so on for the region under interest of the that is according to the region that is being created. Okay, so this is an overall picture of this data structure, and I'd like you to we have seen also how to execute a snakemake rule. In particular, you would like to add 2 more minutes about how to execute a rule, because we saw a simple rule that is the download OSM data, but I would like also to show you exactly the build cutout. And if you see the build cutout, in particular, you see that as input elements, a feature input, this means that this rule requires these 2 files as input, which means that if they are not available, the rule before is executed to create this output, and so on. But it's interesting to notice the output. You see here that as an output, we have cutouts and in brackets cutout. This one is a so-called wildcard. And this means, and in particular, cutout is a wildcard that during the execution may
David, please,
assume
if you please increase your font increase.
Oh, I'm sorry. Absolutely. Very sorry. Okay. You can see here that we have as outputs cutouts, and in brackets there is the keyword cutout. On demand, so when using the workflow, this word cutout inside the code will assume the value depending on how it is executed. Why I'm saying this? Because if you want to create your own cutout, you won't be able to do the cutout as we by running the snakemake rule as we did before. For example, snakemake J1. So one second, that I have to check. So first of all, we need to make sure that the build cutout feature is enabled. Now it's false. So it's a good example to show. Let's say if we want to do, let's say that we want to do this rule. When we run it, there will be an error, because it says no rule to produce build cutout, but we have the rule build cutout. The problem is that it has not been enabled, because there is this condition, this if, and in particular, if we go in enable in the config file, we see config enable, and then we check build cutout. I go into the config, there is the feature enable, and here we have build cutout that's false. Since it's false, that rule is not available. So let's make it true. If we make it true and we run the same, another error will appear, because it says target rules may not contain wildcards. In fact, if we go into this rule, we see that we need a wildcard. If you want to create a cutout, in this case, what you need to do is to do this. Snakemake J1, it's fine. Cutouts / Africa 2013 era 5. 2013 is should put to be this. Let me check to be sure. The tutorial. 2013 era 5 tutorial. .nc. This is going to work. And in fact, it's being executed. So this is to show that the rules that need these quantities in brackets cannot be called as we did before, but they need to have you need to specify the wildcard. And for example, one way is the one that we have seen. So before leaving, I'd like you to show, I will ask you if there are questions now, but before leaving, I would like to give you also another feature that is really needed for running the code offline without snakemake, because also this is possible, and it's very, very useful to debug and understand what's working and what's not working. Are there questions?
Yeah, so my question remains same. So for the last couple of days, I have continuously trying in Discord. So some real issues in difficulties in installing. So how to resolve that? So unless
maybe
and until
we can do this. Maybe later we can find some minutes and tackle exactly that issue to make you solve it. You are on Discord, right?
Yeah. Max.
Okay, we can
already
find a time and we
giving
can
me
fix
some
it.
ideas, but it is not fixed yet.
We can. I think that's best to find 5-10 minutes.
Best is suppose if
that.
you give some time, and so that we can basically share my screen as well. Maybe it will take a few minutes, and unless and until I can,
but
so it is problem.
maybe
I am also using
later.
Windows.
Okay, good, awesome. Okay, as a last part to all, I'd like to show you how to run the code, because now we have seen how to run the code using snakemake. So we need to activate PyPSA-Earth, and then we can do, we have seen everything. But this may not be so comfortable when you need to, for example, debug and understand, for example, why an error occurs. Let's say that you execute the snakemake and an error occurs. How to understand it? The best way is to use this button here. You see this button? It's called Run Python File. And if you click on the link here, there is also the debug feature. And they are both very, very useful. If you go, for example, and how is this useful? Let's get a Python file, and in this case, the retrieval data bundle. This file has the goal of downloading data that are stored into the data folder. We have one way to execute this rule is obviously snakemake. We have seen the download OSM data. We can run this one that you are more familiar with. So we have run this script before, and so you are familiar with how to run it. So jol download OSM data. But the same can also be done using display. However, you have to, before doing play, especially the first time that you use Visual Studio Code, you need to do view, command palette, and you can search Python select interpreter. Select interpreter. And here you need to make sure that the PyPSA-Earth is specified. If you then specify it, this is needed because when you are going to click on the run button, it will use the PyPSA-Earth environment to execute the code. And now the downloading is going to execute. But now, let's say that I make a mistake. And here I remove the G. So this is, so my God, I interrupted it. May I hope not to have made a disaster. Okay. Sorry. I forgot that I put China here, and so the download will take kind of a lot. So I go back and put again Nigeria. And I execute again the retrieve data bundle, and you have seen that by running play, we can execute it. But remember that now, sorry, it was download SM data. I changed I introduced an error here. I removed the G. Now, if we run this code, again, the PyPSA-Earth will be activated, but an error will be thrown. In fact, it says key error EOS. This means that it doesn't find the value EO CRS because in fact it's not there. Let's see that you want to understand why the error occurs. You can click the button here and the red button that is a breakpoint will appear. And now instead of run, you can use debug. If you use debug, then the code will be run and the code will stop whenever there is a breakpoint. In fact, in this case, we can see, and it's interesting because we can explore the value of these quantities. If I move the mouse, for example, on snakemake, all the details will appear regarding the content of snakemake. But let's say that I want to do more complicated things. I can copy, for example, this link, and I can go into the debug console. And here in this block, I can execute any Python code I may wish, also changing the values of the elements. In this case, I want to see the content of this quantity. In particular, we can see that the EO CRS is not there, but GEO is. In fact, we can understand the problem was this one. As a little remark, is that this is for advanced, the last remark is for an advanced concept, is that sometimes the problem may not be in your code, but in the code developed by someone else. In particular, for example, in one of the imports. And while some imports are of PyPSA-Earth, some others are not. For example, let's see. For example, I want to find an element. For example, let's see. Okay. For example, I want to see the run filter. First of all, it's interesting that if you click on control in your screen and then you click on the code and you can jump directly into the code. And this one is you are inside the environment that you are using. This is the original Python code, and you can put a debug here. You could put that, but if you run with the normal debug, as we did before.
See, if you please once again repeat the procedure to jump.
Yes. Control, the button control, and then you just click on the element. CTRL, and you click on the component. This applies everywhere. So if you click control, also in the text here, you see that the word gets underlined. You can, if you click here, you can see where this quantity has been defined.
Thanks.
You're welcome. Let's say, for example, now we have country. This is very basic, but if I click control and I click on country, you can see that the cursor goes back to where country has been defined. The same applies everywhere, which means also if we click on the imports, and that can be very, very useful. In this case, we went to the OSM filter and I tried to put a breakpoint here, but when I debugged that, if you noticed before, it became gray, which means that it was not active. This is because normally you don't debug the imports in the environment. but it could be possible to do that. And it is possible by setting up this block that is run and debug. In this case, I've already set up it here, but I can do it in the other element, in the other repo. If I go into the run and debug here, this will be the fresh screen. If you can create a launch JSON, you can click here. Then you can create a debug configuration starting from a default one, and in particular the default one for a Python file. And this configuration is being opened. In particular, you find the default debug configuration that is this one. This default configuration, it's equivalent to when you click debug as we did before. But notice this, just my code. This just my code means that only your own code is being tested. If you want to debug all the code, we can simply copy and paste to create a new configuration that we are going to name it no just my code. And we change just my code to false. This configuration is exactly the one that I created on the other side. In fact, if you go here into the JSON file, it's exactly the same configuration that we created on the other side. And in this case, instead of running the debug from here, I removed the run filter. There is still the breakpoint. In this case, I can find here the new configuration, not just my code, and run it from here. In this case, when the debug will be executed, it will stop also at the other folder. And in fact, we are now in OSM filter, and the debug has occurred. So we could investigate all the values that are contained here. This is maybe a more advanced concept, but I think that it's worth knowing, because sometimes problems arise in other packages that may not be ours, and it's a good idea to have an idea about how to manage it. So I'm a bit late. Many sorry for that. We started a bit late, but I mean, I went through the plan that was supposed to do, and I'm open to questions. Maybe briefly. Also, you have the registration. So for anything, you can go through the registration, and also we are absolutely available for any comment, any question. And regarding the installation problem, we can set up a session so to solve and fix that. Maybe we could also record that if you agree, so that this problem may be a solution also to others.
Yeah, sure.
Okay, Davide, fantastic. Okay. Like, I think we went into a lot of details. The good thing is we have stuff recorded now. And there's a super ton of useful parts we learned today from that details. It gives you definitely another power, some of that, you know, debugging also your imports and that kind of stuff. I mean, that basically means you can contribute to any open source project and fix your problems that you locally have. You know, with proprietary software, it's not always possible to adjust things, fix things. So it brings you a lot of flexibility. Okay, I think the next session is then Katja.
Yes, thank you for absolutely amazing introduction.